In a previous lecture, we discussed geologic time. In particular, we looked at relative age dating, which provided us some rules to determine the relative age of geologic features, like rocks, and structures, like faults and folds. We also introduced the idea that the Earth is 4.5 billion years old, based on absolute age dating techniques such as radiometric age dating. In this lecture, I will discuss the idea of, or the presence of, unconformities, and that is, when we look at sedimentary rocks, frequently we find that there's some part of the record missing, and these missing parts are called unconformities. At the conclusion of this lecture, you should understand how unconformities form, that they represent breaks in the geologic record, and you should be able to tell me about the three types of unconformities. Let's start by taking another look at the geologic time scale. As was discussed in class, the geologic time is broken up into eons, eras, and periods. And I've asked you to memorize the Precambrian, all of these periods. You're not responsible for the Paleogene, the Neogene, or these different epochs. And of course, we'll look later at how we came up with these numbers, where the Earth is 4.5 billion years old. So let's apply the geologic timescale to a series of sedimentary rocks. This is an example from your textbook. Here is a sketch or a model of a series of sedimentary rocks and a cross-cutting igneous dike. And we can tell the relative age of these events based on the principles of superposition and also using the fossils. So if we apply the fossils to the geologic timescale, we see that the red sandstone was deposited in the Pennsylvanian, the tan sandstone in the Jurassic, and the gray limestone and shale was deposited in the Tertiary time. But note that we have some missing parts of this time scale. For example, in this exposure, there are no rocks of the Triassic or Permian time. And there are no rocks found from the Cretaceous period. So this is a little quirky. As I mentioned before, these breaks in the rock record are called unconformities. And they're very curious. But we can figure this out. Let's start by looking at different rock forming processes. This is a diagram from your book, and it shows how the different rock types go through various rock forming processes within this cycle. For this discussion, what's important is that all three rock types can go through processes when they're at the surface of weathering or erosion, which produces either dissolved elements or fragments. And that's emphasized in this slide, where weathering and erosion can be impacted, or the three rock types can be impacted by these processes. Now this process results also in the transport and deposition of sediment. But what's important for this discussion is that what this means is that where these rocks are located, the eroded features or the fragments or dissolved elements are removed from these locations. Okay? And if there are no sediments in these areas, then there'll be no lithification, and therefore no formation of sedimentary rocks. So the explanation for unconformities is that erosion and other sedimentary related processes are not occurring at those locations for that time period, and therefore we have no record from that time period at that location. The erosion processes can occur by a variety of means, including through rivers, glaciers, wind, and wave action. The important part here is that at that one location, the sediment's removed and therefore has no opportunity to become a sedimentary rock. And that's how unconformities are formed. There are three types of unconformities. And the first one we'll look at are angular unconformities. This diagram illustrates the process through which angular unconformities form, and with time going in this direction. So first of all, we have deposition occurring below sea level. After formation of the sedimentary layers, they're tilted. And then a new series of sedimentary rocks are deposited on these tilted beds. The is shown here for the Grand Canyon. Here are tilted sedimentary rocks. Overlying those are the horizontal sedimentary rocks that are younger. And this arrow points at the angular unconformity, which marks the periods of tens of millions of years of lost geologic time for this area. It's not that the geologic time is lost, it's just that at this area erosion was occurring and the sediments were carried away. So the sequence of events then are deposition of these rocks, tilting through tectonic processes such as faulting and folding, and then more deposition of these horizontal sedimentary rocks. This is a spectacular example. The next type of unconformity is called a disconformity. Once again, time going in this direction. We have sedimentary layers that are flat-lying, deposited below sea level. Some of the layers are eroded when it's brought to the land surface. With a new rise in sea level, erosion has occurred because during this part, so there's this irregular surface. But with another rise in sea level, more sedimentary rocks are deposited. And notice that there is all these layers are horizontal, but there's a boundary between one that is marked by a period of erosion. What does that look like in the sedimentary record? Here's another picture from the Grand Canyon. Here's a series of interlayered sandstones and mudstones. Here is an erosive surface right here, and then we have this massive sandstone here, and this boundary is the disconformity that marks a time of erosion and no formation of sedimentary rocks. Now the way I remember this is that D for disconformity corresponds to deposition. Okay, so the angular unconformity I think is pretty easy to remember, and one way to remember the disconformity is through the process that's occurring, D for deposition. The third type of unconformity is called a nonconformity. Here's a sequence of events. So we have had deposition on the land surface, flat-lying sedimentary rocks. Now, later in time, there's a period of plutonicism and metamorphism, and the sedimentary rocks are uplifted and eroded, and the plutonic and igneous metamorphic rocks are brought to the surface and eroded as well. So at this time, we have metamorphic and igneous rocks to the surface. We have a small remnant of the previous time of deposition. With subsequent rise in sea level and deposition of more sedimentary rocks, that boundary here between the flat-lying rocks and the plutonic, igneous, and metamorphic rocks is the nonconformity. Here is another example from the Grand Canyon. Here's a sequence of events, and there is the nonconformity. These rocks here are metamorphic schists and gneiss, approximately 1.7 billion years, and these are sedimentary rocks that are approximately 700 million years. So this nonconformity marks a time period of almost 1 billion years of geologic history that has been removed from this area. That is, erosion has occurred and carried away that sedimentary, those sediments, and therefore there's no sedimentary rocks forming. So to summarize, there are three types of unconformities: the angular unconformity, which is fairly easy to remember, I think; the disconformity, where D stands for deposition; and then the nonconformity, which is a boundary between metamorphic or igneous rocks and younger sedimentary rocks. This is the last slide, and here's a slide that shows where some of these ideas started by a guy named James Hutton. So this is in Sychar Point, which is in Scotland. And here is a close-up view, and actually you can see the tilted layers here. This is Hutton's unconformity. There are these shale layers, which are at a high angle, and then these tilted layers, which are sandstone. These shale layers are 425 million years old. They are overlain by sandstones, which are 345 million years old. So that leaves us a loss of 70 million years of geologic time where erosion was occurring. Now, when Hutton discovered this, he was with a colleague named John Playfair, and this happened in 1800s or so, 1805 to be exact. And this is what Playfair's recollection of this finding in the field was. I quote, "On us, who saw these phenomenon for the first time, the impression will not easily be forgotten. We felt necessarily carried back to a time when the schist on which we stood was yet at the bottom of the sea, and when the sandstone before us was only beginning to be deposited in the shape of sand or mud from the waters of the supercontinent ocean. The mind seemed to grow giddy by looking so far back into the bits of time, and whilst we listened with earnestness and admiration to the philosopher," that would be James Hutton, "who was now unfolding to us the order and series of these wonderful events, we became sensible how much farther reason may sometimes go than imagination may venture to follow." I hope that you understand unconformities, how they formed, and what they indicate, and please feel free to ask questions. Thank you.